All right, this video is going to cover note 6.2c, which is sketching polynomial functions. The only difference is this time they're not factored for you already. So you're going to have to factor all these, which means if you don't know how to factor, there's no point in even watching this video because you're not going to be able to do it. So make sure you can factor, and let's go ahead and get started. The first thing that they're talking about here is the behavior of the Xintercepts. What that means is if you have anything to power of 1, so like imagine like x minus 2 to the power of 1, so you have your X-intercept, this is a straight through. Your line would cut right through that X-intercept. All right, whereas if it was like x minus 2 to the power of 2 or 4 or 6 or anything even really, you would have your X-intercept and it would bounce and it would not cross. This is a bounce. And then the last one would be like if it was to the power of an odd number, like 3. So like x minus 2 to the power of 3. These are concavity changes. So what that means is if you had your x-intercept here, it almost looks like a cubic function. It kind of like changes concavity there. Hope that made sense. All right, moving on. You also need to know what the end behavior, like what your arrows are going to look like at the end of the line. So if you have even functions, they're either up, up, or down, down. If it's a positive leading coefficient, then they're up, up. If it's a negative leading coefficient, then they're down, down. And then for odd functions, if it's a positive leading coefficient, it's a down, up. And if it's a negative leading coefficient, it's an up, down. So before we even start anything really, if you don't know this right here, you're not going to do well on this. All right. So when you approach these problems, the first thing you need to do is you need to factor. So like here's this equation fully factored. It would be negative x minus 5, x minus 5, x plus 2. Which is really like this, negative x minus 5. I have 2 of those, so it's squared x plus 2. And that x plus 2 is to the power of 1. So this right here is it in factored form. The degree is, this one is degree 3. I get that by adding up all these exponents, the 2 and the 1, to get to degree 3. The leading coefficient is this minus sign out in front. That means the leading coefficient here is negative. So it's an odd function with a negative leading coefficient. So my end behavior is an up-down. The number of zeros matches the degree, so 3. And the x-intercepts. This one's going to have one at x equals negative 2 and one at x equals 5. And the one at negative 2 is a straight through, and the one at 5 is a bounce. And I'm getting that from this right here. I'm taking each of these factors, for example, x minus 5. I'm setting it equal to 0 and solving. So like that's how I'm getting x equals 5, for example. And in terms of the straight through or the bounces, I'm looking at the exponents here. So this x plus 2 to the power of 1, that's my straight through since it's to the power of 1. The x minus 5 to the power of 2, that's my bounce because it's got that degree 2. All right, so if I was approaching this problem and I needed to graph it, the first thing I would do is I would put my arrows on the graph. So I'm going to have an arrow here going up and an arrow here going down. So that's the first thing I do. And I know that from my end behavior right here. All right, the next thing that I would do is I would put the x-intercepts on the graph. So I've got one at negative 2. I've got one at 5. All right, now another little piece of information that I advise you go get is your y-intercept. Y-intercept. You have to just plug in x equals 0 to go find it. So like I would take this equation right here and make all the x's 0. And I would solve this out. So this would be negative 25 times 2, so negative 50. So I know I'm going to have a y-intercept down here at negative 50. That's just another dot you can use to help you draw this line. So now I'm just going to go and connect the dots and pay attention to bounces or straight throughs. So like at negative 2, I have to cut straight through there. I have to hit my y-intercept, and then I have to bounce off at negative 5. And that's all you would do for that line. Okay, moving right along, this next one, factor it fully. So this is going to be x plus 5, x minus 4, and this one's going to be x plus 5, x plus 8. So notice there's two x plus 5s. So when I write this in factored form, it's going to be x plus 5 to the power of 2, and then x minus 4, and then x plus 8. And both of these other ones have power of 1s. So the degree of this, add these numbers up. So I'm degree 4 here. My leading coefficient, there's no leading coefficient here. There's no number right here. So when that happens, it's a 1. You imagine it as a 1. So my leading coefficient here is a positive number. So this is a positive even. Positive even in behavior goes up, up. The number of zeros matches the degree, so 4. The x-intercepts here, remember you take these factors and you set them equal to 0 and you solve it. So I would have 1 at -8. I would have 1 at -5, and I would have 1 at 4. The one at -8, notice the exponent's a 1, so that means it's a straight through. The one at -5, notice the exponent's a 2, so that's a bounce. And the one at 4, notice the exponent's a 1, so that's another straight through. Now in terms of graphing this, the first thing I would do is I would put my arrows on the graph. So I have an up, up, just like that. And then I would put my x-intercepts on the graph. So -8, -5, and 4. And then my y-intercept, again, it's not mandatory, but I would probably go get it. So I would take this equation right here and plug in 0 for x. So it would look like this. 0 plus 5 squared times 0 minus 4 times 0 plus 8. So that's going to be 25 times -4 times 8, which is -800. So it's just down here. It doesn't need to be to scale. You just want to know if it's positive or negative, really. All right, now I'm ready to connect the dots. Just pay attention to your bounces or straight throughs. So at -8, that is a straight through. Then at -5, I have to bounce. Then I have to go hit that y-intercept. Then I have to cut through at 4. It's a straight through, and then I'm done. So it would look something like that. Okay, 2 more. Same thing. On these, I would start out by immediately factoring everything. So like this is going to be negative x plus 4, x plus 4. And then this other side is going to be x minus 5, x plus 4. So notice I have 1, 2, 3 x plus 4s. So when I write this in factored form, it's negative x plus 4 is going to be cubed. And then I also have x minus 5 to the power of 1. So the degree is 4. Add up those exponents to get it. The leading coefficient is this negative out in front, so it's a negative. So on a negative even degree, it's a down, down in behavior. The number of zeros make it match degree, 4. The x-intercepts, I've got 1 at -4 and 1 at 5. Again, I'm just taking this factor like x plus 4 and I'm setting it equal to 0 and solving. That's how I'm getting -4. All right, now at -4, this is a concavity change since it's degree 3. And at 5, since it's degree 1, this is a straight through. So I would start this out by putting my arrows down. It's a down, down. I would put my x-intercepts down at -4 and at 5. I would go get my y-intercept by taking this right here and plugging in x equals 0. So that'd look like this. So that's going to be -64 times -5, which is 320. So it's up here. All right. And then now I'm ready to draw my line. Just pay attention to the concavity change or the straight through. So at -4, oops. So at -4, this is when it's going to concavity change. And it doesn't have to look great. You just, and even, you might even put like CC on your graph. That way your teacher knows that you did a concavity change there. But anyways, go hit that y-intercept, and then I cut straight through at 5, and then I'm done. All right, which brings us to our last problem. This one, this is a 4-term, so you're still going to need to factor it. Factor by grouping, so you'll get x squared minus 9, x minus 6. But this goes for all of them as well. Don't assume you're done factoring just because you factored one time. This right here is still a difference of squares. So this in factored form, I'm going to do that difference of squares and get x plus 3, x minus 3. Then I still have my x minus 6, just like that. So this is fully factored form now. So it's degree 3 because I add up all these exponents. 1 plus 1 plus 1 is 3. My leading coefficient, there's no number here. So when there's no number, it's a 1. So that's a positive leading coefficient. So on a positive odd function, it's a down, up in behavior. Number of zeros make it match degree. The x-intercept, take these guys and set them equal to 0 and solve it. You'll get x equals negative 3, x equals positive 3, and x equals positive 6. So now I go to my graph and I go ahead and put my arrows down. So I'm going to have an arrow down, and then I'm going to have an arrow up. I'm also going to put my x-intercepts down. So negative 3, positive 3, positive 6. And by the way, all of these are degree 1. So that means all 3 of these x-intercepts are going to be straight throughs. So I don't have to worry about bouncing on or concavity change, which is nice. The last thing I do before I start graphing is I would take this equation right here, and I would plug in x equals 0 to get my y-intercept. So that would look like this: 0 plus 3, 0 minus 3, and 0 minus 6. So that's going to be 3 times negative 3 times negative 6. So what's that, 48? No, 54. All right, so in regards to if it was 48 or 54, I really don't care. I don't care if it's off by 6. What I care about is that I put that dot on the correct side of this axis. So like, you don't want to put your y-intercept here when in reality it's here, because it's going to throw off your whole graph. But the difference of it being here or here doesn't really matter. So we'll just say it's here, 54. Cool. All right, now I'm ready to connect my dots. So all these are straight throughs, so just cut straight through, and you're done. All right, so some key takeaways would be, you're definitely going to have to be able to factor it. If you can't take it from like standard form to factored form, you're not going to do well on this at all. And then the next thing I would say is, you need to know this in behavior right here. This is so important to know where to like put these arrows, for example. And then another thing I would say, you absolutely have to know the behavior of the x-intercepts. And then one more piece of advice, go get that y-intercept. It'll help you so much. So hope this video helped.